Okay, so in this video we are actually going to start the curriculum from the grade 11 course, and it is in both the M and the U, and it's this idea of functions. So we're going to start with some general information about functions and then move into specific functions as we go throughout the course. So first thing is, you have been dealing with functions since grade 9. We're just going to give a little bit new vocabulary, a new way of thinking to it. So whenever you have two variables in math, that's considered a relation. The most common letters we use are X and Y because that's what we put on the XY plane. So we're used to graphing on a Cartesian or an XY plane. X is always the independent variable, it's always on the horizontal, and it's considered our input number. Y is considered the dependent variable, it's the vertical and it's the output. Because we've worked with equations already this year, like y equals 2x plus 1, which would be a line. But I could pick an x, put it in, and get an answer for y. Or we could also have a parabola or a quadratic. So I have y equals x plus 3 squared minus 3. Again, I could pick any x, input it, do the math, get the answer, and that answer or the output will be my y. So everything that has two variables, most of them are x, y. It could be a and b, it could be s and t. The variables could be anything. But if it has two variables, it's considered a relation. Only some relations are functions, and this is the definition. A relation is a function if each input gives a unique output, or each x has only one y. So let's look at a real-life example that demonstrates this. Let's say you get a new job, and your pay is going to be $100 a week plus $5 for every shirt you sell. You might be selling these door to door. You might actually be working in a store doing it. Now, I could use any letters. I could short form this and say pay is 100 plus 5 times S, or I could use y equals 100 plus 5 times x. Exact same thing. So these are all relations. They have two variables. One uses words. Mathematicians are too lazy. So then we're going to go to letters, and we could use P and S, but we could also use Y and X. But your pay, your Y, depends on how many shirts you sell, your X. So Y is the dependent, and that's your pay. X is the independent. Now, this would be a function, because if I input one shirt, I will get one pay, $105. If I input 10 shirts, I will get one pay. I'll do 5 times 10 plus 100. I will get 150. And you want this to be a function because you don't want to work in an instance where if you sell 100 shirts, you might make $600, 5 times 100 plus 100, or maybe you'll make $200. So if you inputted 100, you might have an equation or description in words that said, well, it might be 600 or it might be 200. You don't want that. You want every number of shirts you sell to correspond to one unique pay. So this is going to be a function. An important concept when it comes to function, and I'm going to go back to that pay one in a second, is the idea of domain and range. So domain is the set of all possible inputs. So those are our x values. And then the range is the set of all resulting outputs, which are our y's. So those are two definitions. So let's go back to our pay is 100 plus 5s, or y equals 100 plus 5x, depending on which ones you use. So x is our input, and the domain represents all the possible values we can put in there. Well, I have to be careful because I can't put in negatives, so x can't be negative because I can't sell negative shirts. Perhaps I lose shirts and I owe money to the company, but if we're saying X represents the number of shirts you sell, we can't sell negative shirts. X could be 0 though. You could have a week that you sell no shirts. X can be really positive numbers. And this is where there's not always one answer. You could just say all positive numbers, and you could say it would be possible to sell 1 million shirts. But we know, okay, probably you're not going to sell 1 million shirts. If we had more details, we might say, you know, you could sell up to 100 shirts. This might be 500, this might be 50. But when you're not given a lot of details, you are free to kind of think about what's a reasonable answer. And there are 30 of you in the class. I could theoretically get 30 different ideas of what's reasonable. And as long as they all make sense, then that's good. And X also can't be a decimal. You can't sell 1.5 shirts or 2.5 shirts. So the domain is the set of all X, where X can't be negative, X is 0 or bigger, and it can't be a decimal. Mathematicians are lazy. We do not want to write that with words. So we're going to come up with a way to write it as a sentence. So D ... is short for domain is. Now we're going to start to learn how to draw some fancy parentheses. So this bracket represents the set of all X such that X is bigger than or equal to 0, because it could be 0 or it could be positive. This is the way we say it. Bigger than 0 or equal to 0, where X is, I'm going to say, a whole number or an integer, because W means if pick a whole number, avoid those decimals. So now, if I put in numbers here, I want to think about what kind of numbers can I get out. Well, I can't get negative numbers out. I can't get really big numbers. I'm not going to make $3 million in a week. So I want to think about what a reasonable range would be. So again, we do the range is the set of all Y such that. Well, if I put 0 shirts into there, my pay would be 100 plus 5 times 0. So if X is 0, Y is 100. So the least amount of pay I'm going to make in a week is $100. So I'll say Y bigger than or equal to 100. And technically pay can be, but in this case it's going to be all nice. So I'm going to say it's going to be a whole number again, because 5 times 1, 5 times 2, 5 times 3, 5 times 100, it's always going to be a whole number. As we move forward, this is going to be kind of less necessary to think about because it's always going to behave the same way. Don't panic if this is still a little hazy. This is something we're going to keep coming back to and discussing all the time. So if we look at our definition of a function, it's each X has only one Y. So each number shirt sell has only one pay, but not everything has a real life application. Sometimes we're just going to be looking at some pictures, and I'm going to start with some pictures we know from our review line. For our review unit, this is a line. So I have Y, X, and this is a Y equals MX plus B. I'm not too concerned with what the M and the B are at this case, but that's a line. I'm going to look at another one. And I'm going to do a parabola. So this is some graph of x minus h squared plus k with the a in front. I'm going to look at a couple other graphs. So this graph is a circle. We haven't talked about the equation for that yet. Doesn't matter. We have the picture. And then I'm just going to do another graph with, that's kind of a curvy S shape. So now, all of these are relations because they have an X and a Y. They're given to us as a picture though. We can test to see if each X has only one Y by using something we call the vertical line test. The vertical line test says you imagine a vertical line sliding across your graph, and we're not worried about the axes, we're only worried about the actual picture itself. And if you only touch it once every time you draw a vertical line, it passes this vertical line test, and it is a function. So this line will be a function. In fact, all lines are functions with the exception of a vertical line, because a vertical line if I look at the equation x equal to 2, and we talked about this in our review unit, so that would be a vertical line at x equal to 2. If I put a vertical line right there, this fails the vertical line test, or the VLT for short, because at that point it touches that vertical line a whole bunch of times. Let's look at our quadratics. And these quadratics look like they get vertical, but they are always opening. So they don't ever go straight up and down. So if I pass a vertical line across my picture, I will only ever touch the function, or sorry, the relation once. Therefore, it is a function because it passes the VLT. Now I'm going to come to the circle. I can draw a vertical line at a whole bunch of places on the circle, and I touch more than once. So here's an x here. This x might be -2. -2 goes with maybe +3, and it also goes with maybe -3. So that x has two different y's that go with it. So this is not a function because it fails the VLT. Now if we look at this one, well, there are some places where I can draw a vertical line and only touch it once. But then there's other places where I can draw a vertical line and touch it more than once, and 3 in this case. This is not a function. It doesn't matter if it passes at some points and fails at another. As soon as it fails at one or more points, it is not a function. So the vertical line test can be used to justify why something's a function if you have a picture and we short form it to the VLT. So if I ask you to explain, saying that it passes or fails the VLT is enough of an explanation. The last thing I want to look at is function notation, because now we're going to start talking about more than one thing at a time. So I'm going to look at an example where I have y equals 2x squared minus 4x and y equals 1/2 x plus 3. So I have two different equations. One is a parabola, one is a line. So I could distinguish them that way. But what if they're both lines or both parabolas? So it's confusing because they're both y equals. So what I'm going to do is just change the notation. I'm going to give this function the name f, and I'm going to give this function the name g. So they came up with a notation that says instead of y, I can say the function of x, or the answer I'm going to get when I put x into an equation, is whatever 2x squared minus 4x. So this is short form that says we're going to sub x into the function called f and get some answers. Our y's are our answers. So this is just a different way of writing y. Over here, this one, because its name is g, I'm going to call it g of x, and that's what the brackets is read as, g of x, which is 1/2 x plus 3. So that means the name of this function is g, and I'm going to get answers, which will be my y's, by subbing x into this equation. So now, instead of having two functions both named y, I have one called f and one called g. So if I say use function f, you know which one I'm talking about. If I say use g, you know which one I'm talking about. It is just a naming system that we use. So for the first one, we're going to find some values. So find f of, whoops, I'll make that a capital, f of -3, g of 1/2, g of a plus 1, that's g, sorry, and f at 2 minus, I'll write down here, f at 2 minus f at 4. So this is just short form notation, and it's really messy. I apologize for that. F at -3 is mathematician's short form that says find the function called f, use x equal to -3, and find your answer. So there's the function called f. I'm going to put -3 everywhere there's an x, and now I'm going to get my answer, and I'm going to use BEDMAS. I never carry this down. This is not math. We're not going to move the -3 over to the other side. This is a mathematical sentence, or our instructions. It's saying find f, sub in -3, get an answer. So if you carry that down, you start to think that maybe f is a variable and you have to solve for it, and that's not true at all. I'm going to focus on this side. I'm going to use BEDMAS. Negative 3 squared is 9. Negative 4 times negative 3 is positive 12. So then I get 18 plus 12. So the answer is 30. That's it. So if I sub negative 3 into the function f, the answer is 30. If I were to think about that back with our graphing, that means the point negative 3 and 30 would have to be on our graph because the number inside the bracket is always your x. The answer is always your y. So now I'm going to do g at 1/2. Well, because it's g, I'm going to go to this function. So that's 1/2 times 1/2 plus 3. So that's going to give me 1/4 plus 3. To multiply fractions, I just multiply the tops, multiply the bottoms, which is going to give me 3 1/4. 1/4 plus 3 is 3 1/4. And I'm done. Notice I don't carry that down because I don't want to be tempted to see that as math. Those are just my instructions. G at a plus 1 is 1/2 x plus 3. That's the definition for G. In this case, my x is a plus 1, and because it has more than one thing happening, I have to use brackets. So this is going to give me 1/2 a plus 1/2 plus 3, or 1/2 a plus 3 1/2. I distribute the 1/2 in. 1/2 times a is 1/2 a. 1/2 times 1 is 1/2. I have my 3, and 1/2 plus 3 is 3 1/2. So the last thing I'm going to do is f at 2, subtract f at 4 for this. Again, you have to really see this not as math that you're going to do with f and 2, but instructions. This means find the answer when you sub 2 into f, and then subtract the answer when you sub 4 into f. So it's like a code, and I'm going to use my definition. These should be capitals. It doesn't matter if they're capitals or small, but usually it's consistent within the question. I'm going to use my definition of f, which was 2x squared minus 4x. I'm going to sub 2 in first. So that's going to be 2 times 2 squared minus 4 times 2, which is 2 times 4 minus 8, which is 8 minus 8, which is 0. So I did 2 squared to get 4, 4 times 2 to get 8, 2 times 4, and then I subtracted the 8. So this answer, when I sub 2 into f, the answer is 0. Now I'm going to repeat the process with 4. So f of 4 is 2 times 4 squared minus 4 times 4, which is going to be 2 times 16 minus 16, which is 32 minus 16, which is 16. I just used BEDMAS and figured it out. So then I come over here and I put that. So the answer when I sub 4 into the function called f is 16. So my answer to the total question is negative 16. So that was part A, working with f and g. Part B asks us to sketch f in g. Well, this is why we spent time reviewing last unit. Okay, I'm going to start with g because it's actually ready. G is a line, 1/2 x plus 3. So my y-intercept is positive 3, and my slope, or my rise over run, is 1/2. So sketch means that you can do it on graph paper or you can do it on line paper and just make it logical. My y-intercept's at negative 3, and then my slope is 1 over 2. So I'm going to go up 1 over 2 and get my line. Unfortunately, we are going to have to do a little bit more work in order to graph f, because f is a parabola. So f at x is 2x squared minus 4x. I know it's a parabola because of the x squared, but it's not in vertex form. So this is where I have to complete the square or do the funky zero that we talked about last unit. So I have 2x squared plus 4x, so I'm going to take the 2 out. There's no number at the end, so I don't have to worry about that. If it makes you feel better to put plus 0, you can do that. So I take 2 out of the x squared and 2 out of the negative 4. Then I'm going to do 1/2 of negative 2 which is negative 1. Negative 1 squared is 1. So my 0 is going to look like plus 1 minus 1. The first three things always collapse into two brackets, which are the same, so we can put a squared, and the number that goes with our x is always that. So x squared minus 2x plus 1 is x minus 1 squared. Then I have to bring the negative 1 out of the bracket, which gives me a negative 2. So now this vertex is positive 1, negative 2, opposite same. It's opening up because of the positive 2. And I have a double pattern happening, so I'm going to double my second set of numbers. We never touch the first. So 1, negative 2 is going to be about there. From the vertex, I'm going to go over 1, up 2 in both directions. And then I'll go over 2, up 8. And again, it's not perfect. It's just a sketch. But it's important that we did the review from last unit. So those are my two graphs for F and G. Now C is asking us, are they functions? So are F and G functions? And they both are. All straight lines except vertical lines are functions, and all parabolas opening up or down, because if it opens sideways it's not a parabola, but basically all lines with a few exceptions, those vertical ones, and all parabolas are functions, but both will pass our vertical line test. If I lay a vertical line test along G, the pink one, my line, it passes. If I lay a vertical line or apply the vertical line test to F, my parabola, it also passes. So they are both functions. Now here's where we are going to go back and link it to domain and range. So give domain and range of both. And a thing I teach my students to try and remember, because the hardest thing is which one is x and which one is y. So try and think about dx, ry. Domain is always x, range is always y. So let's look at G first because it's the line. So I'm going to set this up already. So domain is the set of all x such that. Range is the set of all y such that. The vertical line represents such that. Now, domain talks about our x or our inputs or our left and right. This line goes all the way left or right, and I can put any kind of number in for x that I wanted to. I could put a positive, I could put a negative, I could put a 0, I can put a fraction, I can put a decimal, I can put anything there. And the graph is going to go all the way to negative infinity and all the way to positive infinity if I'm thinking left and right. So the domain is really anything. All numbers work. So how mathematicians say that is they say all real numbers or all the numbers that exist. That's too much writing, so they came up with a notation with it. So the domain is the set of all x such that x is every real number. That's a curvy E. It's an element sign in math. So this means where x is an element of the real, that's just math speak for all numbers. Let's look at our y values or our outputs. This line is going to go all the way up eventually, and every y will have a point associated with it, and it's going to go all the way down. Using this equation, I can get positives, I can get negatives, I can get zeros, I can get decimals, fractions as my answer. There's no limiting. So again, it's all real numbers. The only difference in this case is that we're speaking about y. So how we say the output can be any number, y element of the real. Now we're going to look at the function called f. And again, I'm just going to get my domain and range ready. The domain is the set of all x such that. The range is the set of all y such that. Now if I look at this parabola, just like the line, the parabola will go all the way left and right eventually. It will keep opening this way and it'll keep opening that way. And there's no restriction on what I can put in for x into the equation. So again, it's all real numbers. So instead of writing that as a sentence, mathematicians came up with a short form, x element of the real. Here's where we have to be careful though, because if I look at my heights or my y values, this parabola will keep going all the way up to the top. But there is this lowest point that's associated with the vertex, and nothing exists below -2. That means it doesn't matter what kind of numbers I input in here, I will never get an answer less than -2. Nothing in the graph exists there. So again, you could write that as a sentence. The range is the all y such that we won't get answers lower than -2. Mathematicians came up with a way to do that too. Y is bigger than, because it's above, or equal to -2. So we're just using symbols to represent the sentences that we would write in math. And that's just a fancy bracket. I kind of ran out of room and squished it in. Now, your homework for this, I want you to attempt these questions. We will have time tomorrow in class to go over any questions. And remember, you are to pick up your textbook from Mrs. Heinonen in the library, but page 235, number 6, 7, 11, 13, and then number 16, only look at A and C. So don't do any of the other ones from 16 except for A and C. And I'll go over any questions and we'll talk some more about this tomorrow.